You're wired in. Smallcapvoice.com. Following is a presentation of smallcapvoice.com, today's leader in investor relations, capital formation, and retail support. Now, with your online business briefing, smallcapvoice.com's Stuart T. Smith.
Welcome one, welcome all to this online business briefing brought to you by smallcapvoice.com, where we shine a spotlight on some of the smartest and freshest plays here on the small and microcap market. We're welcoming back to the show PositiveID Corporation. They're traded under the ticker symbol PSID, and we're lucky enough to be joined by the president of the company, Lyle Probst. Lyle, how are you doing today?
I'm doing well, Stuart. Pleasure to speak with you again.
Thank you so much for taking time to call in and speak with your company shareholders as well as our listeners. Now today, we want to start with a background for those who are not familiar yet with Firefly Dx. Now listeners, we've got so much information here at smallcapvoice.com via audio interviews as well as the articles we've written about Firefly Dx. But Lyle, as background, please describe what the Firefly Dx is and what markets you look to address and why you believe it's better than existing detection and diagnostic systems. Go ahead, Lyle.
Okay. The Firefly Dx is designed to be a handheld diagnostics device for a point-of-care market. It allows the end user to be able to test for organisms or pathogens wherever the sample is being taken, whether it be in a clinic or it be out in the field where there aren't laboratories or capabilities readily available to be able to test for diseases or pathogens. It's an advancement over what's currently available in that, one, it's portable, it can be run by anybody, it's very simple to use, and it provides the same level of results that you get from a laboratory test. Currently, most samples are taken at a clinic or a hospital. They're sent off to a lab. It takes several days, several hours to get results back from those. With a Firefly device, those samples can be taken, and those results can be achieved within less than an hour at the point of taking the result. So it's much more advanced than anything that's out there currently, and the intention there is to be able to speed the time to results in order to take appropriate action depending on what the pathogen is. Take appropriate action much sooner to minimize the impact.
Well, with that information, earlier this year, PositiveID did announce that it successfully detected the Zika virus on the Firefly Dx breadboard prototype system. Now, how long does it currently take to test for that virus in a lab, and why would point-of-need detection be better?
So the first part of the question there, that we did detect Zika earlier this year, and it currently takes about a half an hour to test for that virus. That's a test that we put on our system that was created by an assay partner called Generation. We used their test, their assay, on our device, ported it over successfully. We've done several different assays from other partners on our device, and the time to result with any of them has been roughly about 30 minutes, as compared to a laboratory, which can take anywhere from as quick as 4 hours up to 24 hours to achieve the same results. And with our system, there's no difference in the data that's produced. There are systems out there that are fast, but there's a compromise in the data that comes out of it or the results that come out of it. Whereas one of the objectives in designing the Firefly was to maintain laboratory quality results, and that's something that we've been able to achieve. So that makes it, the system as a whole, you asked, why is it better? Why is that detection better? Well, it's because you're getting the results right away, and you're not compromising on the level of results that you receive out of running them on a handheld.
So is there anything unique about the Zika virus itself or testing for it that makes it maybe more difficult than, say, Ebola or something like that?
There are a lot of similarities with Ebola. The Zika virus is an RNA virus, much like influenza, and it requires, without getting into the weeds of it, it requires an additional step to take place in the processing before detecting the virus itself. And what we've done in our instrument and in our cartridge that runs on the instrument is we built in that additional step, that capability, to be processed automatically and very quickly. That extra step, which is called a reverse transcription, in a laboratory typically takes about 45 minutes to an hour to perform just that part of it. On our cartridge, we've been able to reduce that time down to 1 minute without compromising the results. And so by automating that process, having it in the cartridge, we can detect something like Zika, an RNA virus, or an influenza, or an Ebola, still within that roughly 30-minute time frame, as opposed to a laboratory, which is going to take many more hours. So what makes it a little more difficult is that extra step. And then you look at where Zika's occurring now, it's out in areas that maybe don't have access to the clinics or the laboratories like we do here. Similar to when the Ebola outbreak happened. The facilities weren't close by where the outbreaks were taking place. Therefore, it's very difficult to take samples and to be able to get them back to a lab in order to be processed, get the result, and then take appropriate action to help the individual that may be affected by the virus. With a Firefly device, you can take that sample from the person at the point of need and have the results while they're still right there in front of you, and then be able to take the appropriate action, appropriate countermeasures to be able to help that person in a much more effective way than what happens currently.
So in addition to Zika, what else has Firefly Dx detected in the lab, and can the system test for any pathogen? We did just talk about the differences and similarities to Ebola. What about some other pathogens that it can test for?
So it's designed to use the laboratory standard real-time PCR, and that's the method of detection that's used worldwide. And because we chose to go with that method, we can test for any type of pathogen that is out there, that there's a test for it. We can port it onto our instrument. So what we've put on it so far is, Zika, obviously. We've done Ebola testing on it. And there's a whole long list of several different strains of influenza, E. coli. We've done antibiotic-resistant strains of bacteria such as MRSA and MSSA. And we've done viruses, both RNA viruses, DNA viruses, and the bacteria, a whole range of them, including the bioweapons, potential bioweapons such as anthrax, plague, and several others. It's quite a long list, but the capability is there to detect pretty much any type of pathogen as long as there's a test, an assay developed for it that we can port onto the cartridge or onto the system itself. So as far as use case scenarios for the Firefly, it's pretty much unlimited. It can be used in a clinical setting, or it can be used out in the field in remote settings where there's remote outbreaks. And it covers the whole range in between, from agricultural pathogens to human pathogens to animal pathogens can all be detected on the same device with the appropriate test loaded onto the cartridge.
So what development remains to complete Firefly Dx? Do you intend to launch Firefly Dx on your own, or would you be thinking about partnering with a larger company?
So the first question, what remains on the development to complete the Firefly? So we have prototype units in our lab that we're running these samples on. Every sample that we run is done completely on our own hardware. That's our own design, and it's all our own intellectual property. We don't use any third-party instrumentation. And what we've done on these prototypes shows that all the proof of concept, all of our design, all of that is working. The next phase of it for us is to do another generation of the cartridge itself with some improvements that we've identified in the development process. Once we complete those, which we're currently working on now, the plan is to go into the handheld format. That design is complete, and it's just waiting for the final iteration of the cartridge to be complete before we produce the handheld version of it. Now, the prototypes have all the hardware that'll be required in the handheld. We just haven't packaged it into that form factor yet because it'd be a little bit premature until the cartridge is final. That being said, we expect to be at that next iteration of the cartridge within the next few months, by the end of this year, and be able to have handheld prototypes in 2017. As far as launching the Firefly, yes, if we plan to do it on our own or to partner with a larger company, we are looking at both of those options. We do have plans in place to be able to launch it ourselves, but we are also in conversations with other companies that may have an interest in partnering both in the final development of the system for their particular needs and also in regards to launching it as a product on the market. So it depends on how things develop over the next 8 to 12 months as to how we plan to launch it. But our time frame for launch is we are looking to launch it by the end of 2017 as a product.
Well, listeners, once again, we are speaking with PositiveID Corporation. Ticker symbol for that company is PSID. And once again, we're lucky enough to be joined by the president of the company, Lyle Probst. Now, listen, there's news out on the press wire today. Using that ticker symbol PSID, you can find just a slew of press releases from this company who does an excellent job of keeping their shareholders and potential investors apprised of what they're doing. They're also available Twitter, Facebook, LinkedIn. They're also, of course, at PSIDcorp.com. Well, Lyle, thank you so much for your time and insight today. We look forward to great things from you and your company here in 2016 and well beyond.